Good evening, dear all. Let us continue the chapter with the topic dimensional analysis. Now, what is dimensional analysis? We will understand with few more words. Physics is a complete subject of words converted into language and understanding what is asked and your interpretation about the question. Simple. Okay. So let us first understand the terms or the words like dimensions of physical quantity. Now what is the meaning of a dimension of a physical quantity? It is the power to which, it is the power to which the base quantity is raised to represent that particular physical quantity. To represent that particular physical quantity is called as the dimension of that physical quantity. So it is the power to be raised to what? To the base quantity to represent that physical quantity. Just I will give you an example. We know the formula of volume. What is the formula of volume? Volume is equal to L cube. That is known to us. Clear? Now, this same formula, we will write it in the terms of the power to the base quantity. Here, which is the base quantity? L. Normally, any physical quantity is written as the power of three base quantities, that is length, mass and time. And it is always written in capital letters for dimensions. And that dimensions and the base quantity are always written within a square bracket. We know the volume of an object is L cube. Fine. So we have written it as L cube, but now how to write it as a dimension? We will write it as square bracket as I just now mentioned, capital L as I just now mentioned, and cube as I mentioned just now. Okay, cube because L cube is the formula. Now, what about the powers of M and T? The powers of M is 0 because it is not there in the expression. L is 3, T is 0, and we complete it with a square bracket. This is the dimension which we have written for the volume. Now, what is the dimension of L in this? 3. So, we read it as dimension of in M is equal to 0 in this expression. Dimension of L is equal to 3 in this expression. Dimension of T is equal to 0 in this expression. Another expression, different dimensions of M, L and T. So this is the way you write dimension of a physical quantity. You write its formula, you put it in the square bracket and understand, note down the dimensions of L, M and T, which are the base quantities. Now, what is the dimensional formula? The expression that shows how much the base quantities were raised to represent that physical quantity, that is called as a dimensional formula. So, what is dimension? Dimension are these numbers to which that physical quantity is raised, and what we wrote just now, M raised to 0, L raised to 3, T raised to 0 is called as the dimensional formula of that quantity. Clear? So 0, 3 and 0, they are the powers to which the base quantity is raised. That's why they are their respective dimensions. When we write it or we express it as how much the base quantity is raised to express or represent this quantity of volume, then this is called as a dimensional formula. When we equate the physical quantity, which physical quantity we are talking about here? Volume. So when we equate the physical quantity to the dimensional formula which we got just now, then we have equated the physical quantity to the dimensional formula. V is the symbol of volume. So this expression or this equation is called as a dimensional equation. Clear? So 0, 3, 0 are the dimensions. The expression which we wrote for this physical quantity is called as dimensional formula. If we equate the physical quantity symbol to the dimensional formula, then it is called as a dimensional equation. Clear? So all these three words you have to remember: dimension, dimensional formula and dimensional equation. Dimension, dimensional formula, dimensional equation. For the same physical quantity volume, I have taken a very simple physical quantity for you to understand. Clear? Okay. So I will just move. You please take a pic of what I have written just now. We will go to the next part of the same video. Keep watching. Okay. Now we go to find out the various dimensional formulas, basic dimensional formulas. Okay, we have already written V. Fine. Like that we will go volume we have written. Like that we will just try to understand how to derive the dimensional formulas and write the dimensional equations of various physical quantities which we will come across in this chapter. One by one we will go, we will correlate them also. Fine. Okay. So let us go first to distance. What is distance? Distance is having the base quantity L. What about M? M is 0, L1, T0. I write it in the square bracket. Then we can also say displacement, it is the same. This is the first one. Second one, I am just taking randomly. Velocity or speed. What is the formula first? Displacement on time. So, what is displacement? Symbol for physical quantity L. For time T. L only one displacement. So, I have written 1. Time T is in the denominator with 1 power. So, T minus 1. And what about M? M not there. So, 0. Got it? Slowly you go. Don't worry. We will learn. But initially, you have to go slow. Third, acceleration. What can I write? Velocity upon time. Okay, velocity I am ready with. So I will write. I am ready with the dimensional formula of velocity. Is it necessary to write m raised to 0? Yes. Though it does not have a dimension, 0 is the dimension of m. Is it necessary to write? Yes. Is the sequence of the worry? No. Not necessary to have MLT as a sequence. You can shuffle the sequence. But once you write the sequence, you keep it throughout. for the numerical when we use it. Fine. Divided by time. What is its dimensional formula? T. We don't have the base quantity m nor we have L. Now here t raised to 1. So I have to take the t raised to 1. So up. So what should I write here? L1 t minus 1 because this 1 has gone up, m raised to 0. So what is my dimensional formula for acceleration? L1 t minus 2 m raised to 0. Fine. Again I shall write it so that you remember it. Acceleration dimension formula is L1 t minus 2 m raised to 0. I can as well write it as m raised to 0 L raised to 1 t minus 2. I can write. I can bring t in the between also. So this is the dimension formula of acceleration. 4. Let me take force. Force is equal to ma, mass, into acceleration. Just now we got dimensional formula for acceleration. So I will write m, mass is there, so m raised to 1, and acceleration just now was m raised to 0 L1 t minus 2. So I write it. So when multiplication for the same base, then I have to add the power. So for m, what will I do here? 1 plus 0. L raised to 1. T raised to minus 2. So what is my answer for force? Dimension formula m raised to 1, L raised to 1, T raised to minus 2. Do not forget to keep the square bracket. Square bracket means you are writing the dimensional formula. Clear? Going further, as the space of the board finishes, I continue. After force, we can write work. What is work? Work is force into distance. All these formulas you have learnt already in your classes of 9th and 10th. Same formulas I am writing here. Just now we derived the formula for force. What was it? M1 L1 T minus 2. Yes? Multiplied by the distance. So now calculating this part, what do we get? M raised to 1. L has 1 here and 1 there. So L raised to 2. T minus 2. This is the dimension of work. Dimension formula for work. Okay. Going further, we can write power. Power is equal to work upon time, which is equal to work. I will write as it is from here. Every time deriving it may not be convenient for you to maintain this speed. So some basic dimensional formulas you remember as by hearted. Fine. So m raised to 1, L raised to 2 as it is. T is minus 2 here. If I take 1 up, it will become minus 2 minus 1. That is minus 3. 1 raised up, minus 2 minus 1, negative 3. Now what? So power. Now remember, for work and energy and potential energy and kinetic energy, for all these terms we have the same dimensional formula. Okay, so power we have written. Now after power, I'm just thinking by myself naturally. After power, we can go to pressure. Pressure is force upon area, correct? So force as written here, will write down the same dimension formula, m raised to 1, l raised to 1, t minus 2, and area is length square for any body, okay? Meter square, length square, like that you remember. So we have to only work upon length. M, write as it is, length, power 1 minus 2. So 1 minus 2, negative 1. Clear? 1 minus 2, negative 1. Or to make it clear, 1 negative 2, that is the power of L. L, 1 minus 2 I wrote up. T minus 2. So what is my answer? M1 L raised to minus 1, T raised to minus 2. That is the dimension formula for pressure. Clear? Okay. Then we can write impulse. Impulse is equal to force multiplied by time. Okay. So what is force dimension formula again? M1 L1 T minus 2. Time is T. Both are up, T raised to 1. So M, I don't have a partner here, L, I don't have a partner here. So I just write it as it is, M1 L1. Now T has the power minus 2 and 1. So minus 2 plus 1 is negative 1. So T raised to negative 1. That is the dimension formula for impulse. Now momentum. Momentum is equal to mass into velocity. Now you have to remember what was the dimension formula of velocity, or again go to the formula and derive it. So mass m raised to 1, velocity m raised to 0, L raised to 1, T raised to minus 1. So combining these two dimension formulas, M has the power 1 here and 0 here. So what do I write here? 1 plus 0, 1. L1, T minus 1. So in this way, try to either derive and remember, or remember it with practice, not by heart. Clear? Like this type of, as many formulas you practice, these are the basic. This much also if you learn, you will be able to solve many numericals. There are many other dimensional formulas which are derived in your textbook, in the last pages of the textbook, appendixes. Okay? So from that, whatever your respective teacher is finding out or making you derive, you learn. Otherwise, so many basic quantities are enough. Clear? So you take a pick of what we have done just now for both the pages which we have derived for the dimensional formula. I shall move. First you take the previous pick, previous page pick. I shall move. And take the next pick. I shall move. So in this manner, you find out the dimension formulas of various physical quantities. Learn them first, because in the applications of dimension formulas, we have to use these formulas. That time you cannot sit and keep deriving. Okay, am I clear? So these two pages, derive, learn them, keep it in your mind, and then only we can move to the next section of dimensional analysis, which is application of dimensional formulas. Fine. So I end this video here. In the very next video, I will go for how you are applying the dimensional formulas. Okay. Take the pick. Fine.